I continue on the lesson. So here we have to see what do we have to do when we have fractional exponent. So I can show you the lesson here. So yes, I need green. The lesson here says if I have, so let me see what's going on. So x, I have x power a over b. It's root b x power a, and now I can use the same thing here. So I can say, so when I have any fractional exponent, I can use the denominator as a root and the numerator as power. So it is this 4 power 3, okay? And when I have root 2, I just don't show, I just show radical, okay? So this means root 2. So for root 2, I don't show, and for everything else, yes, I do it. Okay, so if I have fractional exponent, which I'm going to see many times, I have to have this guy in the denominator and this guy in top. Okay, sorry, here, right? Okay, and then I can use my calculator and find the answer. Okay, so for this course and also especially in the future, if you see something like these questions, like you have fractional exponent, you can change it to root and power and those things and use your calculator and find the answer. And if calculator gives you the answer, if it's whole number, you can write the answer. If it's a decimal number, you can round it based on the question. So the question gives you maybe guides you, or based on rounding appropriately, which you are going to see in future. Okay, but in this lesson I want to go further, and I want to show you, and I want to give a good exercise for your brain to learn how to simplify these kind of questions. I mean these kind of radical questions or roots. Okay, so these are very good questions for your brain and your exercise for your brain, and they also help you for future, that you need to learn how to factor. For math 270, you need to factor, you need to learn how to factor. So for algebra, so you can factor, and also you can use that method. You can practice now and then use it later in math 270. Also, Math 273 is not really easy course. This course right now is not hard, but when you move to 273, all of a sudden you feel, wow, it's a hard course. So right now you really have to work on basic, because when you move on to Math 273, you really have to be good in basics, because otherwise you are going to have hard problem. Okay, so Math 171 is not hard. I know you can handle it. So sometimes you feel, well, it's not a hard course, but I want to assure that you have a very good understanding of basics, because when you move to 273, you really have to be good in basics to learn new things and then have a good mark in that course. Okay, so that's why here I try to give you more challenging and more exercise for the more challenging questions and more exercise for your brain, um, because the lesson is not hard, but we need to see harder questions just to work on them and to learn different techniques and different approaches. Okay, just to be able to handle math 273 easier. Okay, so again, if I have a fractional power, I can use roots and power. And then how can I find the answer? Here I can use my my calculator. Okay, so for now, okay, so here, this is here which I'm going to do it. Okay, so this one is 4 power 1 over 2, which is radical 4, and that's 2. Okay, I use my calculator. This is radical root 3 or cube root of 8, which is again 2, and it is fourth root of 16, which is again 2, and it's 5 root of 32, which is again 2. Okay, so so you can use your calculator again and find the answer. So how about this one here? So it is a radical 4 cubed. I told you when I have 2, I don't need to show it. I can just write radical. When I see radical means root 2. And this is 64, and this is 8. How about this one here? This is 3 root 3 27 power 4, which I can use my calculator and say, okay, so it is 81 is the answer, okay? But I want you to learn how to show me this. What do we do here? Okay, so for example, in this case, I have radical 4 cubed, okay? Because I have radical means root 2. So, but I see power 3. So so here I have to just go further and find the answer. So the answer is 64. Okay, what is that? That's 8 squared. Okay, I have power 2 and I have root 2. So they cancel each other and the answer is 8. How about here? This is cube root of 27, 27, 27, 27. Okay? Which is cube root of 3 cubed, 3 cubed, 3 cubed, 3 cubed. Okay, because I have cube root, I have to try to change my number to power 3. And when I do that, then I can cancel. See, this and this I cancel, 3 comes out. Okay? This and this cancel, 3 comes out. This and this cancel, 3 comes out. And this and this cancel, 3 comes out. So from each, 3 comes out. Because I have power 3 and I have root 3. Okay? So, emphasize here. You will see x power a over b. You use b as root and a as power. Then you can use your calculator and find the answer. Yes, I know. But I want you to have more exercise and try more. So what do I want you to do? I want you to try to factor. If you have radical, try to factor to power 2. If you have root 3, try to factor to power 3. And then you can cancel those power and roots. And when you have the same power and the same root, that number comes out. Okay? Again, my calculator gives me the answer. I know, but I want you to learn what happened. The next thing is simple radical. Okay? If I say, what is a square root of 4, you can tell me plus minus 2. Because 2 squared is 4, minus 2 squared is also 4. I know, that's correct. So if I tell you in sentence, any language, answer is plus minus. But when I ask what is radical 4, I cannot say plus minus 2. No. What is the reason? The reason is when I talk about radical, that's principal second root. And principal n root is always positive. We define it. We define that to be positive. That's a definition. Look at this. It's positive. If you go to your book, if you purchase Wiley Plus, you go to your book, I think it's page 18 or 20 that you can see. You can see that radical 4 is 2 and radical 4 is not minus 2. Look at here. Radical 9 is 3 and is not minus 3 because I define radical to be positive. But if I say what is a square root of 4, the answer is plus minus 2 because I just say, because that's a fact. When I do 2 squared is 4 minus 2 squared is 4. I know. But when I show this symbol, because I define this symbol to be positive, to have a positive answer, I cannot accept negative 2. However, I see many times a student, they use radical 9 plus minus 3, radical 16 plus minus 4, radical 25 plus minus 5. I accept it because they saw it before and I know what they mean. But mathematically, when I use the symbol radical, the symbol is defined to be positive, so I cannot use negative. Okay? So now, if there there is a square root, and I ask you, okay, so what is the answer? So you have to see, find the number that if you square, you go to that answer. So what do I mean here? See, here I have x squared equals 16. What is the answer? Okay, x squared equals 16. So if I put a number and a square, the answer must be 16. Oh, 4. Yes, 4 squared is 16. How about minus 4? Minus 4 squared is also 16. Oh, yes, both of them. But right now I told you not plus minus. I said this. See, here you have x squared equals 16. So that's equation. When you have an equation, you have to test all the answers. So here x is plus minus, because both of them work, plus minus radical 16. But what is radical 16? Radical 16, based on what I said here and based on this definition, is always 4. You see plus minus because of the equation. Plus minus 4. So there is no conflict here. There is no conflict. No. Sometimes when I say this, a student, they say, how about this one? There is no conflict. Still radical 16 is 4. I see plus minus because x squared equals 16 and both of the answers are working for me. That's an equation. I have to test all the answers. How about this guy? X cubed equals 27. X is plus 3. Why? Because 3 multiple 3 is 27. How about minus 3? Minus 3 doesn't work. No. Because if I do minus 3, it's minus 27. So this one doesn't work. Okay? So how about this? It says write a radical. So I write radical 36 and the answer is just 6. Remember, because I define this symbol to be principal second root. Principal n root must be positive if you have a positive number on there. But if you have negative number for principal 3 root or principal 5 root, the answer is negative and you will see. Okay? I define. That's a definition. So how about here? 5 root 32 squared, which is 5 root 4. What did I do here? I use my calculator. How about if I say I don't want you to use your calculator, I want you to show me why. Okay, you do this. 36 is 6 squared, and then I have s squared and I have a square root. I can cancel. This is 6. How about here? This is 5/5 root 2 power 5 power 2, which is 5th root 2 power 10, which is 2 power 10 over 5, which is 2 power 2, which is 4. Yes. Or I can say that, or I can say it's 5th root 2 power 5 times 2 power 5. And from each I can bring 2 out. I told you, if you have the same power with the same root, you can cancel and bring that number out. Okay? But if you don't have the same power, the number stays inside. Okay, so again, many times I see a student, they say plus minus 1, and I understand what they mean. But mathematically, I accept. I don't reduce mark, but mathematically it's wrong. Because I define radical to be positive. That's a definition. If you see your book, I think page 20, page 20, that's radical 4 is not minus 2. Okay, so it's plus 1, plus 1, plus 1. However, here, if you have minus 1 under the radical, because it's cube, minus 1 works. Minus 1 is the answer. So here, but minus 1 must be under radical. Okay, so here, so 2, 2, 2, 3, 3, 3, 4, 4, 4, and 5, 5, 5. Okay? How about here? Solve this. I cannot find any number in real number that if I square the result to be minus 16. I can't. So if I do a squared, the result will be minus 16. It's impossible. What happens if I use my calculator? If I use my calculator, it gives me error. I see error. Okay, so what should I do then? Okay, I say there is no answer in real number set. I can't. A does not exist in R, real number set. So, how about other sets? Okay, imaginary, yes. I can say this, it is radical 16 times radical minus 1, which is radical 16i, which is 4i. Yes, but this is imaginary set. Done. Okay, how about this? So, as I said, I want you to be very good in just basics and principle of math. So, because then you are going to have easy time and just easy time in math 273. So it's going to be smooth for you. Okay, so what do you do here? Okay, you have x power an even number, means 2, 4, 6. Okay, equal positive. How many answers you have? 2. See, if I have x squared equal 4, I have plus minus 2. Both of them work for me. Okay, I can accept this. How about if I have x power 2 equal negative? Doesn't doesn't exist. I don't have any x. But remember, I don't have any x in real number set because in imaginary number, yes, I do. What? Okay, here I can say x squared is minus 4. So x is plus minus radical minus 4, which is plus minus radical 4 times radical minus 1. I'm sorry. Which is plus minus 2i. Yes, but this is imaginary number set, not real number. So in real number, no. In real number, if I have x power 2, 4, 6, 8 equal negative, there is no answer. How about odd numbers? Yes, odd numbers, they work. X power 3, 8. The answer is, so positive, yes, it's positive. Just one answer. X power 3 positive, just one answer. And x power 3 negative, let me see. Yeah, negative, just one answer. So here x is 2 and here x is minus 2. Okay, so you can see this. Look at that. So it's minus because you have cubed. Okay, so cube can be negative. Yeah, doesn't matter. Okay, how about this? If I have x cubed equal a, I just use cube root to find the answer. If I have x cubed equal minus a, so I use cube root. Doesn't matter. So I can know this and use it. Right? So now, let me see what's going on. This page doesn't have anything. Oh yes. Okay, so now I want to show you. As I said, you can use your calculator for radicals. Also, you can simplify them. How to simplify them? I told you, when you have radical, you have to try to make everything base power. So change everything or factor everything to power 2. Then you can cancel. What do I mean? Look at this. You have radical 25. So you do radical 5 squared. And then you have a square. You have a square root. You can bring 5 out. Okay? So, when I see a number on the radical, first of all, I can use my calculator to find the answer. I know. Even I can use my calculator and I see the answer is this decimal. Doesn't matter, that's the answer. I can round it. But if I say I want you to simplify it, means I want you to show me why. What was the answer like that? If you want to know the reason, you have to know this. You have to divide the number on the radical, which is radicand, by 4 or by 9, by 16, by 25. Why? Means you have to factor to this number. Why? Because this is 2 squared. This is 3 squared. This is 4 squared. This is 5 squared. That's 6 squared. That's 7 squared. So, and I told you I need to see a squared because I have a square root. When I have a square root, okay, like here, I want to bring the number out. So I see a squared and a square root. So I try to simplify that way. I try to factor. Okay, look at this. I have radical 96. I know I can use my calculator. Radical 96. And the answer is 9.797 blah blah blah. Okay, so I know that's the answer. But I tell you I don't want. I want you to simplify it. Okay? This is a good exercise for your brain. Maybe in future we just, for example, in math 273, you just see find the answer using calculator and just round it. Doesn't matter. It's okay. You can do that. But if you learn how to factor and how to simplify, you can use that method and technique for future factoring. These are good exercise for your brain. Okay, so what did I say? Divide 96 by 4. And then divide by 4 again. Okay, so what happened? It's 4 times 6, which is 2 squared times 2 squared times 6. Can I bring 2 out? Yes. Can I bring 2 out? Yes. How about 6? No. Okay, so I make it smaller maybe. So it's this 4, 6, which is 2 squared, 6, which is 2 radical 6, which is 4 radical 6. Radical 50. Okay, I divide by 4, doesn't work. I divide by 9, doesn't work. I divide by 16, doesn't work. I divide by 25. So 25 times 2, which is 5 squared times 2, which is 5 radical 2. Radical 2 doesn't come out. What happens if I use my calculator? Just the answer is decimal. That's fine. But as I said, maybe in future you just in math 273 you just use your calculator. But here it's a good exercise for your brain. You are learning how to factor. You can use that method in future, and they are good exercise. And it's very good that you see what is the reason behind the calculator answer. These are very good exercises for your brain, and we are learning basics. So here, 48 divided by 4. Okay, so it is 4, 4, 3, which is 2 squared, 3, which is 4 radical 3. 2 comes out, 2 comes out. Okay, these are come out. This is coming out. This is coming out. How about that? It's 4 times 13, which is 2 squared times that. 2 comes out. 13 stays because I don't see power. Okay? So, how about if I have, instead of just number, I have variables. For example, a, x. Doesn't matter, the same thing. But here I have to say a and x again and b are positive. I have to say, otherwise it will be negative on the radical, and so I would say there is no answer. So positive. Okay, so here it's radical. I think it's very unclear, so I write it here. So it's that. So you do a squared a. Why I separate them? Because it's a square root. Because it's this and this. So I can bring that out. How about this? This is 36 x cubed, which is 6 squared x, which is 6x radical x. That's 8 squared. Okay, I have to mention what is the question first, and then 8 squared x squared x squared x, which is 8x radical x. That's 8x squared radical x. How about that? It's 45b cubed, which is 3 squared times 5 times b squared times b, which is, which one comes out? Here. Which one comes out? This one and this one. So it is 3b radical 5b. Okay? So far so good? Now I can continue here. So how about for these radicals that are not squared? Okay, if it's not squared, instead of I divide by 4, I divide by 2 cube, I divide by 3 cube, I divide by 4 cube. Okay, because it's cube root. Okay, so what happened here? Oops. 3 cube. What comes out? 3. Because I have the same power and the same root, so that comes out. How about here 16? I have I have root 4. When I have root 4, I divide by 2 power 4. So I try to make it power 4. Here I try to make it power 3. Here I try to make it power 4, and here I try to make it power 2 because I see root 2. So it is root 4 2 cubed, 2 power 4, which is, the answer is 2. Okay? 2 comes out. Okay, now we reach to this lesson, how to simplify and so add and subtract radicals. I want to show you this because it's helpful for your for future, for derivative in math 273. You will see them, and they are not really hard, so you can learn them. They are very easy. Okay, so if you see the same radical, for example, it's the same, just for example, I am doing the same like terms, I am adding like term. Okay, in addition and subtraction, when you see the same radical, you just add them, doesn't matter. So you have 2 apple plus 3 apple. How many apple you have? So it is 2 plus 3 radical 3, which is 5 radical 3. Done. So you will, I know you can use your calculator and show me this answer as decimal. I know. Show calculator for this, for this, and then add them. I know. But it's good that you know it, because it's useful for your math 273 when we do derivative with first principle. So you will see this. So how about here? I have 1 minus 3 plus 5 radical 6, because it's like terms, so they are like each other. So look at this. 2 radicals are considered like when I have the same radicand, means the same number on the radical. Okay, so it is minus 2 plus 5, so it's 3 radical 6. How about here? Okay, so this and this I can add, this one no. So it is minus 2 radical 3 plus 5 radical 2. Can I add them? No, they are not like each other. One of them apple, one of them orange. How about this one? 4 radical 7, yes. So how about this? For this one, we need to do more things because I don't see them the same. Oh, at the beginning I say I cannot add them, but then I notice one of them is 9, one of them is 27, one of them is 3, so maybe I can do some changes. And I continue after. Okay? So this is video 2. Thank you so much. Bye.